So this is 2-3A. I've taken 2-3 from the online textbook, and I've split it up into 3 days. So today, tomorrow, and Friday, we're going over 2-3. So you might wonder why we didn't do 2-2. And actually on your paper, go ahead and correct where it says 2-2 to 2-3A. I've taken 2-2 and I've kind of mingled it into 2-3A, B, and C. Because it follows along with your textbook. Let me show you. So, if you were confused about something, you could go to your textbook. Here in the context part, click Chapter 2. This is 2-3, Conditional Statements. And then open the ebook. And there's your book. And it takes you through the whole section. And again, we're not going to do all of 2-3 today, but we are going to do it spread over 3 days. And then down here on the bottom on this pink one is PT. That's private tutor. So if something doesn't make sense when you're at home, you can click that. Or personal tutor, and then it's also in Spanish if you would rather have it in Spanish. And there's videos on what I'm going over. That's why my notes sections will follow the book sections, so you know where to look if you need more help. And you're already there to do your homework anyway. Okay. So conditional statements. They follow the format of the example. If you are not completely satisfied with, then your money will be refunded. So if, then. If, then statements are conditional statements. There's conditions involved. So these are written as if, and then the hypothesis will follow. Then, and then the conclusion will follow. So the hypothesis, I'm going to underline in red, and it's going to use the letter P. So if P, then Q. So then, and whatever follows the word then is the conclusion, Q. So for conditionals, it's the format of if P, then Q. Okay? So here we're going to underline the hypothesis once and the conclusion twice. So the hypothesis, I'm going to do in red, that's the P. And the conclusion, I'm going to do in blue. And that is going to be Q. All right, so if the University of Texas won the 2006 Rose Bowl football game, then Texas was college football's 2005 national champion. So you see the word if. So what follows if is the hypothesis. And then you see the word then. So what follows then is the conclusion. And of course they don't always follow it exactly that way. Like number 2 says, I'll buy you a book if I have enough money. That's not if then, but you do still see the word if. And there are conditions involved with this. So the hypothesis still follows if, even though it wasn't at the beginning of the statement. So if I have enough money, and you can kind of put the word then in there, then I'll buy you a book. So it still works. You just have to find those key words that tell you what's going on. So next we're looking at truth values. And we touched on this yesterday with inductive reasoning and conjectures about how a conjecture is something that is believed to be true. It doesn't mean that it is true, it's what's believed to be true. So we're going to have to figure out the truth value, the actual is it true or not. And I find the easiest way to figure these out is try to disprove it. Not is it true or false, but like how can I prove this wrong? And if you can come up with a situation to prove it wrong, then it's wrong. If you can't, then it's true. Maybe. Or you just haven't thought of it yet. Okay, so if it is February, then there are only 28 days in the month. So is this true or false? If it's false, then how do you know it's false? What's a counterexample?
Leap years.
Exactly. Leap years have 29 days. So false, because leap year, February, has 29 days. Because most of the time, yes, there are only 28 days in February. So if it's a month with only 28 days, it has to be February. Except for every 4 years, there's 29 days in February. Okay, so if the name of a state contains the word new, then the state borders an ocean. So what is a way we could disprove this?
California.
But if the state contains the word new.
New Mexico.
Yeah, New Mexico. But you are the third person who said it, California today. Well, because I can see it's state borders an ocean. It's like, the reason it's saying California would be
It's true.
if a state borders the ocean, then the state contains the word new. But yeah, this is false because New Mexico does not border an ocean.
No.
So this is false. And once you get a single counterexample, you don't need another one. That's it, just one. All right, so if you live in Houston, then you live in Texas. Can we disprove that?
Yeah, the city in Houston.
Yes. You got a little mix, but because that is true for us. If we live in Houston, we're in Texas, but there is also Houston, New York. There's Houston, Tennessee, and I'm sure there's a lot of other ones that I don't know about. But so false.
Okay, so it's false, but, well, it's saying if you. It's talking about you.
If you live in Houston,
If, yeah. It's talking
then
about you, so
you
it's
live
just
in
saying-
Texas. You could live in Houston.
So it could be true, you know.
Well, it could be true in the fact you could live in Houston, Texas,
If-
but
if it
you don't
wasn't-
necessarily live in Texas just because you live in Houston.
Okay,
You could live in Houston, New York, and then you would live in Houston but not in Texas.
yeah, I mean, if they wanted us to say false, they could say if we lived in Houston.
I'm not sure that would really change the value of it, though. But I see what you're saying, and that's a good way to look at it.
In my point of view.
It is a good way to look at
I
it.
would
Try the
say true.
details.
I would
Well.
say true if this was a test.
Right, that's why we're going over it now, to get you to think about why it's false. It's false because there are other ways. Yes, ma'am.
Okay, but what if you didn't know there was like another person?
Exactly.
Well,
We're making this more
And
difficult.
what if you didn't know there was one?
right. Well, I mean, yes. You're not going to have anything that complicated to have to answer on a test. But that's the thing is Google knows these things. Research. Check it out. I know, but I wouldn't ask you that on the test. Okay, so we're moving on. Attention, back up here. Moving on. There was a lot of discussion on that one. It was a good one. Okay. So now we're going to write a sentence as a conditional statement. Remember, conditional if P, then Q. And state its truth value. If it's false, give a counterexample and maintain the order of the statement. And you might need to add words. So this is just a statement. It's not a conditional statement. A rectangle has 4 right angles.
True.
It's just a statement. We need to write it as a conditional statement, if then. So what I'm going to do is I'm going to say that a rectangle is what I'm going to say is my hypothesis. And then talking about 4 right angles, I'm going to say that's my conclusion. But I need to write if P then Q to make it a conditional statement, because conditional statements are if P then Q. Okay, so if a shape is a rectangle And you can write yours without, you don't have to use the exact same wording as I do, it's fine, as long as it's an if-then. If a shape is a rectangle, then it has 4 right angles.
Is this the whole thing? Is this like, is this what's gonna be on the test, just this?
There's, today's 2-3A. I split 2-3 into 3 days. And then there's the stuff from yesterday, and then there's another section. Be okay. All right, so if a shape is a rectangle, then it has 4 right angles. So we took it and we made an if-then sentence, or an if-then statement, conditional statement. So what is the truth value of this? Is this true or false? If it's false, I need a counterexample. If a shape is a rectangle, then it has 4 right angles.
Oh, wait. True.
It is true. It is a characteristic of a rectangle is to have 4 right angles. So this is true. And then we're going to do another one.
What is P to the G or whatever?
PQ.
Oh.
That's the part of the beginning. If P, then Q. An acute angle measures less than 90 degrees. So we're going to talk about the acute angle for P, and we're going to talk about how it measures less than 90 degrees for our Q. So if an angle is acute, if an angle is acute, then it measures less than 90 degrees. So if P, then Q. If hypothesis, then conclusion. Is that true?
Yes.
Yes, it is true. Because the definition of an acute angle is an angle that measures between 0 and 90 degrees. So that is true. All right. And then one more part to look at for conditional statements is the Venn diagram. This is to, if you want to write a true conditional statement, then you are given a Venn diagram, then the smaller circle, the more constricted information, is going to be the if part or the hypothesis, or P, if P, and then the larger circle, the more broad topic, is the Q. So the then Q. So if P, then Q. So to write this as a conditional statement, a true conditional statement, if you are a drummer, then you're a musician. Now you could write a statement either way, right? We could still write a conditional statement. If you are a musician, then you are a drummer. But it wouldn't be a true conditional statement. It would be false. So this says to write a true one, if you're given Venn diagrams, the inner circle is the hypothesis, the outer circle is the conclusion. All right, so that's conditional statements. That's the original if P, then Q. The other one I'm going over today is the converse. So converse is like the reverse. Converse, reverse. I like to do the word association because you're going to have 5 of these situations of statements. So the original is the conditional statement if P, then Q. And then the second one is the converse. If you do a converse, you're reversing the order. So you have to have the conditional before you can reverse it, right? So this time, P is second and Q is first. All right, so you're interchanging it. The converse of a conditional interchanges the hypothesis and conclusion. Not necessarily all the words move because of English to make it make sense. Sometimes the words do funny things, but that's not the logic part. That's just our language part. Okay, so we're given a statement. It's not conditional. Supplementary angles have a sum of 180 degrees. So first thing we need to do is write a conditional statement. If P, then Q. And then after we write if P, then Q, we can do the converse of that and do if Q, then P. All right, so I'm going to say supplementary angles is what I'm going to make the P. And the sum of 180 is going to be the Q. All right, so again, if your words don't match mine exactly, it's okay. But I'm going to talk, so if angles are supplementary, if angles are supplementary, then they have a sum of 180 degrees. All right, if angles are supplementary, then they have a sum of 180 degrees. If then, if P, then Q. That's a conditional statement. Once you have a conditional statement, you can make a converse statement, because the converse is the reverse. So if Q, so if they have a sum of 180 degrees, then angles are supplementary. I'm just going to abbreviate with SUPP. So we have a conditional and we have a converse. So now for the truth value, the conditional, if angles are supplementary, then they have a sum of 180 degrees. Is that a true or a false statement? It is true. Because supplementary, S, straight line, straight angle, 180 degrees. What about if you read the converse? If they have a sum of 180 degrees, then angles are supplementary.
True.
That is also true, which we'll talk about biconditional statements tomorrow and how a definition is a good biconditional statement. But if it doesn't work both ways you say it, then you probably don't have a very good definition. All right, one more example. Given perpendicular lines form right angles. Oh, the given is perpendicular lines form right angles. So the first thing I want to do is I'm going to do an if. My conditional statement is if P, then Q. And then I'm going to make a converse statement, if Q, then P. So if P, I'm going to talk about perpendicular lines. So if lines are perpendicular, and the symbol for perpendicular is the upside down capital T. I know that was in yesterday's assignment and not everyone knew that. Upside down capital T, that means perpendicular. All right, and then I'm going to use the right angles to make a conclusion. Then they form right angles. Okay, so now that I've made a conditional statement, I can flip it to do the converse. But you have to do it, you can't reverse it if you don't have one yet. So you can't go from the given information straight to converse. You have to make the conditional, you're assigning the P and the Q, and then you can reverse them. So if they form right angles, then lines are perpendicular. And I'm just using the symbol. All right, so looking at the truth value for the conditional, if lines are perpendicular, then they form right angles. Just think about like the XY axis whenever on a coordinate plane. Those are perpendicular lines, and yes, they make right angles. So yeah, true. If they form right angles, then lines are perpendicular. That is also true. If that's what it means to have perpendicular lines, is they meet at 90 degrees. So that actually makes a good definition of perpendicular lines, that they meet at 90 degrees. All right, so your assignment is 2-3A in the online textbook.